what is GRASS? So GRASS is just an acronym that stands for Geographic Resources Analysis Support System. And the software has been in development since 1982. And it's been involved with a large number of US federal agencies, universities, and private companies. And at this bottom graph here, I just kind of included a whole bunch of US agencies that potentially have used GRASS. So for instance, I know probably US Army Corps of Engineers used this software at some point. So about GRASS. So GRASS is a free open source GIS software, and the purpose of GRASS is it's used for geospatial data management and analysis, image processing, graphics and map production, spatial modeling, and 3D visualization. All right. So the general features of GRASS that I was able to find out was that it got about 350 modules to render maps and images. And from this, it can manipulate raster data, and then it can also manipulate vector data, including these vector networks within it. And then it also has the ability to process multispectral image data and create, manage, and store spatial data. And then I didn't include this in the slide, but I thought it was important because when I was comparing this and Envy, maybe it's because I've used Envy so much compared to GRASS, but I did find Envy to be a lot more simple than this. This has a pretty steep learning curve, at least to me it did. So now we're going to get into the GRASS GIS capabilities, and there's quite a few of them. But first off, we're going to go over raster analysis. And GRASS GIS, the software has the ability to generate these automatic raster lines and areas to vector conversion. Also buffering of line structures, cell and profile data query, color table modifications, and etc. Then we got 3D raster analysis, meaning it has the ability to produce these 3D data imports and exports, 3D math algebra, 3D interpolation, and 3D visualization. And then from this, we got vector analysis. And that just basically is talking about how this software has the ability to produce contour generation from raster surfaces, conversion to raster and point data format, digitizing and reclassification of vector labels. And then we got point data analysis. And this just includes stuff like triangulation, surface interpolation, topographic analysis, and of course, LiDAR. And then following out those, we got image processing. And this includes, which this is kind of cool because this GRASS GIS can include support for aerial and UAV images. And this is our final slide here going over the capabilities for this. So we got DTM analysis. And this is just referring to contour generation, path analysis, slope analysis, and surface generation. Then GRASS GIS can also do geocoding. And what it means by this is it can do geocoding for raster and vector maps, including LiDAR. And then from this, it can do visualization, meaning that it can produce 3D surfaces, 3D query, histogram presentation, data point maps, raster maps, and vector maps, and generate these map creations, including maps, PostScript maps, HTML maps. And of course, it can do basic geostatistics of the data that you're looking at. And then finally, one of its capabilities is temporal framework, which is referring to the support for time series analysis to manage, process, and analyze spatial temporal environmental data. So where to download this? There's also a Linux option, but most of the time, I think that most people have Mac operating systems or Microsoft Windows operating systems. And the versions available, these are the most three common that I found that were installed, but we got GRASS GIS 7.1.1. This is an old stable version. And the one that I downloaded, which is GRASS GIS 7.8.2, this is the new stable. And then they got one in development right now, which is GRASS GIS 7.9. It's in development and daily builds. And the reason why I didn't install this is because it's not stable. And just to avoid complications, I downloaded the 7.8.2 new stable version of the software. So now we're going to get into how how GRASS produces its data that we're going to work with. And it's important to know that each location, which I hope you guys can see my cursor, so each location has its own coordinate system, map projection, and geographic boundaries needed for a specific project. And then from this, GRASS will create a subdirectory after a location is created under map set here. And then what's important about map set is that map set includes all the files required for the project that you're doing. And this permanent folder right here will always be there whenever you open up your GRASS software. So what it's important to do generally is create new map sets. That way you can keep all your data organized and not just leave it under permanent. So that's important to do. So just to go forward this and put it in another way. So everything is set up through the GRASS database created by the user. So for me, I created a folder on my desktop that says GRASS data. And then whenever I download data, like for this instance, I downloaded a practice data set that was provided by GRASS GIS, and I put it in this database. And then from that data, locations are formed, and they're often referred to as projects. And each of these locations, like we said before, has a map set. And these map sets, again, hold all that data needed for the project. And then, like I said, multiple users, like we see here, can be formed within the map set. And this is just mainly due to keep everything organized and not so clustered. But it's important to note that only the user who created the map set, so wherever you're getting this data from, only they can, of course, modify that data. So putting this together, because this part's pretty important, and just to kind of go over it. So GRASS GIS, again, organizes into locations, and these locations have map sets that contain their own coordinate systems. And these map sets hold that location data, and that just basically means that these map sets hold all that data that's required for that project that you are completing. And then again, that data can only be modified by the creator where you're getting this data from. And we can see this graph here is kind of an example of the startup screen for GRASS GIS that we'll get into here soon. So I'm going to be doing a simple project that I found on the GRASS GIS website. And this data set is taking place in North Carolina. And there is two ways that we're going to be completing this project. But first off, we're going to be using the console command, or what they call the console syntax. And then I'll display how to display this information about this data set. And then right here, this is my startup screen for GRASS GIS. And we can see I got my location here that I downloaded data from the GRASS website, and then I put it in my GRASS data file here, and then it's loaded up here. So we're going to get into these commands first. So we're going to talk about the G command, or G console command. And the importance of this command, and this is the one I used most throughout my project, or throughout this practice project, and the purpose of this is to handle file operations. So for instance, if we type into the console command g.list, and g.list just basically lists all available database files for the user specified data type. And then if we want to take that further, and let's just say we want to look specifically at raster data. So we do g.list space raster, and this will display to us all raster map data available. And then same thing with vector data. We do g.list space vector, and this will display to us all vector map data available. So in this case, I got the figure where I typed in g.list space vector, and it lists all the vector information that I can display within my project. And then we got the R command. I didn't really work with the R command too much, but R command, the purpose of it is it handles 2D raster data processing. So for instance, if we want information, so if we do r.info, and basically this is just displaying information that's associated with a raster data set. But if we just want to focus, like, let's say on elevation, a specific type of raster data, this will display information associated with an elevation data set, which is what I did here in this image, which I did r.info space elevation. It's displaying all that information associated with an elevation data set. And then finally, we got the V command. And the V command handles 2D and 3D vector data processing. So if we want to look at specific vector data processing for something like streams, we'll type in v.info space streams into that console, and it will display information associated with the stream data set, which is what this image over here that I attached is showing. And if we want to take this further, we can do v.info flag C, which is what that hyphen stands for. And this will display the types and names of the tables for the stream vector map. And that flag C, it basically just allows for names of tables of vector maps to be displayed. And all these commands, they are listed within the GRASS GIS website that you can have access to. And then just kind of go over all these again, and just because these are all important. So again, the G command, it's just a general command, and its purpose is just to handle the file operations, whereas your R command handles that 2D raster data processing. And then that V command handles both 2D and 3D vector data processing. And again, the importance of these are essential for finding the basic information about the data set that you're working with. So I got this here, but I figured since I'm sharing my screen, I can probably just work through the data set. So if I go here, all right, so right up here we can see I am my database dictionary. I have my GRASS data highlighted. And then this is the data set that we're working with. This is NC_SPM08 GRASS 7. And we want to click down here, user 1. And if we start our GRASS session, of course, basically I'm just starting from scratch here. That's what that's talking to me about. All right, and then we can see here we got two tabs open. One's a layer manager, and then one is a map display. Well, here we're just focused on this layer manager. And down here at the console, this is what we're talking about. I'm going to first do a command, that G command, G.list vect, or rast. We'll do raster first. And then we could see here that it's displaying to us all the raster information in which we can open up. But the one I want to focus on here is this elevation. Okay, so to display this elevation, I do D, which stands for display. And then I type in rast, because this is raster data, then space elevation. And then we can see in our display here, we got this, and then we click on this icon up here, and it's going to zoom in to our image that we're looking at here. All right, so now we want to look at some vector data that we're going to add to this. So we'll do G.list vector, or VECT. And then we're going to get all this vector information that we can bring up within this image. But for right now, we're going to, first off, and we will open up streams. So to do this, we'll do D.vector, VECT, streams. Now, if I just typed in this, it's going to display in black. So what we're going to want to do is we're going to add a color to it. And all we do to that is we do COL equals, and since it's water, we'll do blue. And now within our display here, we're seeing the streams that is associated with this data. So now let's add another thing. So we got roads here. So let's add these major roads. So again, we'll just do D.vector, and then roads, major, color, and we'll make that yellow. And that's going to show us all the roads within this image. And then just to do a little bit more of a complicated console command, we will display overpasses. So to do this, we'll do D, which is again display vector, because we're focused on the vector data. And then we'll type in overpasses. And then we have to set an icon for this. And we'll do icon equals extra. So for me, I memorized these before I did this, but of course these are all available online for you. And then we'll do extra hyphen bridge. And then we want it to be kind of big, so we'll do a size equals 10. And then F color, and that F just stands for fill color. And since we're using an icon, we want that icon to be a certain color that we want. So we'll do F color, we'll make bridges red. And then here we got all the bridges that are labeled within this. Okay, so that is one way of how this software can be used, is using these console commands. Now I'm going to deselect everything and just start from scratch. And then we're going to do the same thing, except I'm going to show you guys how to use graphical user interfaces using these tools that we see up here. So I got a Mac, so for me, I will go to File, and then I go to Map Display, and we want to add a raster. So then we pull up this dialog box, and we hit this drop-down menu, and then from here we can go to Elevation. And then we put apply, and okay. So it's a lot easier, I believe, doing it this way. And again, so if we want to add some vector data, so we go to Map Display, Add Vector, and then we hit this drop-down menu. And we'll do streams again. We'll start off with that. Hit that, and then over here on this tab, we'll see colors. Do blue, and apply. And again, we can see all that it just labeled there. And we could add our major roads. Hit this. There's a lot of data that we can add, but we're just going to focus on those first three that we did before. And we hit our color, make those yellow. We get all of our roads displayed. And finally, we will do our more complicated overpass. So we'll go to there. And I gotta find it up there. It is, overpasses. We'll go to color. So we'll just do feature color red like we did. Area fill, since we're using an icon, we'll make that red. And then over here, we'll see this symbol. And in this box, we'll click within this box and this drop-down menu at the top. Go to extra, and then we'll see this. We click it, and it's a bridge icon. And we click OK, and we want to make this somewhat more visible, so we'll set that as a size of 10. We'll hit apply, and OK. And there we go. We got all that data that we did before using console commands, just using a graphical user interface. And of course, we can also add shades to this if we wanted to add a shade. Importance of shade, of course, is to me, what it makes it adds depth perception, kind of like a false 3D, makes it more 3D, I guess is a good word for it. But we can also drop down this menu up here and get a 3-dimensional view of this area. And if we hit this, this allows us to move around this area like that. And then if we hit this and the orange one, it will rotate this 3D scene. So we can kind of just rotate it. And we can kind of get an idea of elevation and all by doing this 3D view, which is pretty interesting. It's still got all of our bridges highlighted in red here, or overpasses. Of course, it's a different symbol in all of our streams, and I'm having a hard time finding our roads, but oh, there's one there. But yeah, it's actually pretty nifty. This is just a small data set. Okay. So now to go on to, so we just went through all that. So one thing that I had especially problem with when using this software was trying to visualize blast LiDAR files in this. And the main reason for that is because with Mac, you have to jump through a lot of hoops, and there's a lot of programming, and it's just a hassle. But I decided to go as far as I could with this, and then GRASS, the website, does an example with this. I just took their screenshots just to kind of show how this is done. So basically this area is still in North Carolina, but more specifically Raleigh. And of course this data set belongs to that same sample set that we're using. And this exercise imports a sample last data set covering a tiny area close to Raleigh, North Carolina. So last files are just basically metadata for the use of projecting LiDAR. And with GRASS requires you to have another software called LibLast. And LibLast is just a C++ software that is used for reading and writing common last LiDAR data. But within this is their last file that they obtained. And we'll notice within this, there's no spatial reference. So there's no epsg code. But since this is practice and they already knew what this was, they provided it for us, which is NAD 83 Harn-North Carolina with epsg code of 3358. But if this isn't a practice and we need to find that epsg code, I found a website where we can find epsg codes, which is called spatial reference. So as long as you know the area in which you're working in, you will be able to go up here and type in Ohio, and it'll bring up a whole epsg codes for Ohio, and you should be able to find the epsg code that will be used for your project. Okay. So now we're creating a GRASS GIS location from a last file. So again, we have on the image closest to the left, we have our GRASS database here. And then we're creating a new location. And then from this new location, it's going to open up this dialog box. And of course, we're going to name the project and everything. And I just kept the name that they used, which was NC_NAD_83_LCC. Of course, the location that we're looking at is in North Carolina. And then from us, we got a whole bunch of different options that we can choose from to determine the location that we're looking at. But the most easiest one is selecting an epsg code, which it gives to us. So if we click on that, we click on next here, it's going to bring us up to this dialog box. And we can search for it just by scrolling through, but of course, since we have that epsg code, we just type in 3358. It pulls up our North Carolina area that we're looking at, and then we've created this new location. And then I also created a new map set just to keep things organized, and I just called it landmass. And then this is where I couldn't go any further because I can't open up this dialog box down here. So if we go to import raster data from files, and we click on that, it will bring us up this dialog box here. And the first thing we're doing is we're going to import a file, and this is that last file. So we're going to browse, and you're going to browse to where you have that last data stored, and then you're going to open up that. And then your output raster map, they just named it because they're looking at the 95th percentile. So they just named it here. And then from that, we're going to click on this tab that says statistics. And what they did is they focused on percentile. And of course, they set it to the 95th percentile. And then you have optional data. And they selected two optional data. One was extend region. And they also did override dataset projection. And the reason why I can think that they highlighted override dataset projection is because that epsg code was not included in that last file. So I'm assuming they selected that to avoid complication. And then from this, we got our map being produced, but then we want to zoom to the selected maps. We'll just find that under the drop-down menu within here. And we'll zoom to the selected map that we're looking at. And then it will produce our LiDAR map that we see here. And of course, we use that orange one to rotate around a 3D scene. And they got it already in that 3D view. And that is viewing LiDAR using this GRASS software. And that is all I have for just a basic introduction of GRASS GIS.